In this lecture, I am going to give you a brief introduction of the normal reaction and how to solve the numericals problem based on normal reaction. So, as we have discussed previously, that the normal reaction is nothing but the contact force which is perpendicular to the surfaces in contact. For example, as I have drawn a block, so there is a contact between the block and the surface, so a normal reaction exists here. The ground apply a force on the block in the upward direction. I can say the normal reaction which is perpendicular to the surfaces in contact. So if there is no contact between the ground and the block, the normal reaction becomes zero. There is no normal reaction between the block and the ground once the block uplifted from the ground. So based on this concept, we will solve few numerical examples so that we will become confident regarding the concept of normal reaction. So we have a numerical in front of you and we need to calculate the acceleration of the block. A force of 5 mg is acting at an angle of 37 degree on the block of mass m. So as the force is at an angle of 37 degree, and we know very well that the how to calculate the value of 37 degree, as from this triangle this is 37 degree, this is 90 and this is 53 degree. From this triangle the sides must be 3, 4 and 5. So we can easily solve the value of sine of 37 degree. So here sine of 37 degree is nothing but 3 by 5. And similarly we need to calculate the value of cos of 37 degree because we will need it, and it becomes 4 by 5 in the numerical calculations. Okay, let's solve this numerical. As the force is acting at an angle of 37 degree and its magnitude is equal to 5 mg, as let's say the force is acting in this direction 5 mg, the magnitude of force, so the its value along the x-axis is f cos of 37 degree. We can say this is the force along the x-axis and its value along the y-axis is fy, where fy, that is the force along the y-axis, becomes f sine of 37 degree. So we can solve its value. The value of f is 5 mg and sine 37 degree is 3 by 5. So it becomes 3 mg. This is the magnitude of force along the y-axis. Similarly, we can calculate the value of force acting along the x-axis. It is fx equals to f cos of 37 degree. The value of f is equal to mg. Cos 37 degree is equal to 4 by 5 and it becomes 4 mg. This is the value of force acting along x-axis and this is along y-axis. So now we can calculate the acceleration. So along the x-axis, let's see, we will handle the numerical very easily with particular directions. Along the x-axis now, the net force from the Newton's second law, the net force acting on the block is mass of the block multiply acceleration of the block. So here we will calculate the acceleration of the block along the x-axis. So then net force along the x-axis is 4 mg. It's 4 mg and this is mass. So easily we can calculate the acceleration. The acceleration becomes 4g. This is the acceleration of the block along the x-axis. Now along the y-axis, so along y-axis you can see we have quite a few forces acting on the block in the upward direction, that is the along the y-axis, and its magnitude is 3 mg. The gravitational force is acting in the downward direction mg, and we know that a normal will also act on the block n. But from the diagram you can see that this 3 mg is greater than mg, right? That is the upward force is greater than the mg. It means that the block will accelerate in the positive y-axis, or we can say the block will accelerate in the upward direction AY. As the block will accelerate in the upward direction, so it lost the contact with the ground. As it lost the contact with the ground, the normal reaction becomes 0, right? So in this equation, in this mathematical equation, the normal reaction becomes 0. So I am going to write the net force along the y-axis, as this is the greater force as compared to the downward direction. So upward force minus downward force is the net force along the y-axis. So net force along the y-axis is equal to mass into acceleration along the y-axis. So the net force along the y-axis is equal to 3 mg, that is upward force, minus mg. Normal reaction becomes 0 because the block accelerates in the upward direction due to 3 mg force, which has greater magnitude as compared to the downward force. So normal reaction is 0. So this is the net force along the y-axis equals to mass into acceleration. So it becomes, we have 2 mg equals to mass into acceleration. Mass terms cancel each other. So 2g is the acceleration along the y-axis. So now we have calculated the acceleration along the x-axis and acceleration along the y-axis. So the net acceleration of the block is, to calculate the net acceleration of the block, we solve it something like this: acceleration along y-axis square plus acceleration along x-axis square. This is the magnitude of the net acceleration of the block. So let's solve this. It becomes 2g square plus, and acceleration along x-axis is equal to 4g square. So it comes out to be 4g square plus 16g square. So it's 20g square, or we can say g root 20 meter per second square. This is the magnitude of the net acceleration of the block. In this way we can solve this numerical. So this is our required answer. Let's move to the next numerical problem. Okay, so numerical number second, here we have, so in this case we have two blocks which are connecting with each other. Let's say this is a surface, this is a ground, and here we have one block having mass m1, and this m1 is connected with m2, a bigger block. Okay, so we need to calculate the normal reaction exists here. We know that the two surfaces are in contact, m1 and m2 are in contact with each other, so a normal reaction exists between them. So we need to calculate this normal reaction. Let's see how we can solve this. And a force F, it is given, a force F is acting on m1 towards right. Okay, let's solve this numerical. So first of all, how to solve this numerical? The first step is we need to calculate the acceleration of the system. As only one force is acting along the horizontal direction, so we will consider it as a system. So we will consider it as a system. So in this system we have two blocks, m1 and m2. So we can say the mass of the system is m1 plus m2. Now this is system. Now you can analyze from this diagram that N, that is the normal reaction between the blocks, here is internal force because it is inside the system, and this force F, which acts on m1 earlier, now it acts on the system. So what we can say that the horizontal force which is acting on the system is F. We don't say here it is acting on m1, it is acting on the system, and that magnitude is F along the positive x-axis. Okay, so to calculate the acceleration, obviously the system will accelerate towards the right side. So the net force acting along the x-axis is F, and net force is equal to mass of the system multiply acceleration of the system. The mass of the system is m1 plus m2, and acceleration of the system, let's say a. So from this we can say F divided by m1 plus m2 is the acceleration of the system. As this is the acceleration of the system, m1 and m2 respectively accelerate with the same acceleration, that is a, given by the equation number first. So if someone asks you what is the acceleration of m1, so we will say the acceleration of m1 is f divided by m1 plus m2, and what is the acceleration of m2, same, which is given by equation number 1. So acceleration of m1 and m2 are same, given by equation number first. Okay, now we will approach how to calculate the normal reaction acting between the two blocks. Okay, as m2 is accelerating towards the right side with acceleration a, right? Obviously a normal reaction from m1 acts on m2. So here normal reaction act, this normal reaction applied by m1 on m2. Okay, so we say it's the free body diagram, but in the free body diagram obviously we need to add more forces like m2g, which is the gravitational force, and the normal reaction applied by the ground on the m2. So actually three forces are acting on m2. One is n1, n1 is the normal reaction, let's write n1 is the normal reaction applied by ground on block. Okay, and n is the normal reaction applied by m1 block, right? And m2g is the gravitational force applied by earth on m2 block. Okay, so three forces are acting on m2, but from these three forces n1 and m2g, these two forces are along the y-axis. So we bother not to introduce these two forces in the diagram because our system is not accelerating along the y-axis. So we are not interested to draw these two forces whenever possible. So we are interested only on those forces due to which the m2 block is accelerating. So here the m2 block is accelerating due to the normal reaction applied by m1 along the x-axis. That's why whenever you are going to solve the numerical problems, something like this, so you only draw those forces which are useful in the numerical. So as acceleration is towards the right side, so, or we can see the horizontal direction, so we draw only the forces along the horizontal direction, and here the only force which is acting on m2 along the horizontal direction is n. Okay, so from this system we can write Newton's second law. From Newton's second law, what it says, net force acting on the system is equal to mass of the system multiply acceleration of the system. So here the net force acting on the system is n along the x-axis. Okay, mass of the system multiply acceleration of the system. All right, and we know the acceleration with which it is accelerating. The acceleration is f divided by m1 plus m2, which is given by equation number first. So we substitute the acceleration, so normal reaction becomes n2 f divided by m1 plus m2. This is our required result. Okay, there is one more option. We can solve the normal reaction with the help of a free body diagram of m1, block m1. Let's solve that too. How to calculate from the free body diagram of n1. So let's say this is m1 block, and along the x-axis here force F is acting, and normal reaction in this case acting here. This normal reaction, as this is the common normal reaction between the surfaces m1 and m2, so here I can say this normal reaction is from m2 on m1. Okay, but this block is again accelerating in this direction towards the positive right side. Okay, as the acceleration is toward right side, it means that the F greater than N, then only the block will move towards right. So net force from Newton's second law, net force can be F minus N. This is the net force, right? So net force is equal to mass of the system multiply acceleration of the system. So here net force is equal to F minus N. This is the net force m1, and acceleration is F divided by m1 plus m2. From this we can calculate N. How we can calculate N? Let's solve it. F minus m1f divided by m1 plus m2 equals to, and we rearrange it. Okay, now solve this. F m1 plus m2 minus m1f divided by m1 plus m2 equals to N. Okay, let's open the bracket. F m1 plus f m2 minus m1f divided by m1 plus m2 equals to normal. So here these terms can cancel out. So f m2 divided by m1 plus m2 equals to normal reaction. So again we get the same result from the free body diagram of m1. So this is our required result, that is the normal reaction between m1 and m2. Okay, I hope you understand the concept how to calculate the normal reaction. Let's move toward the three block system. How to calculate the normal reaction if we have three blocks in contact. So example number 3rd. Okay, here we have, let's say this is 3 kg and this is 2 kg and this is 1 kg. Okay, and a force of 24 Newton is acting on the system. All the surfaces are smooth surfaces. Okay, now we have here N1 and here N2. It means the surfaces between the blocks 3 kg and 2 kg apply normal reaction N1 on each other. Similarly, the surfaces between the blocks 1 kg and 2 kg apply normal reactions on each other with value N2. Okay, so we need to calculate the acceleration obviously of each block and the normal reactions N1 and N2. So calculate acceleration of each block. Also calculate the normal reaction N1 and N2. This is our numerical. Okay, let's solve it. So first of all, as all the blocks will move together with the due to the force 24 Newton acting on the 3 kg towards right side, so we will consider these three blocks as a system. So this become a system. Okay, so what's the mass of the system? So mass of the system becomes 3 plus 2 plus 1 equals to 6 kg is the mass of the system. And due to this force, this system accelerates towards right. It means that all the three blocks move simultaneously with the same acceleration A. Okay, from Newton's second law, net force along the x-axis, that is force along x-axis, is equal to mass of the system multiply acceleration of the system along the x-axis, right? So net force is 24 Newton, mass of the system is 6 kg and acceleration A. When we solve this, it comes out to be 6 4 24. So 4 meter per second square is the acceleration of the blocks. So each block, either 1 kg, 2 kg or 3 kg, will move with the same acceleration having magnitude 4 meter per second square towards right, towards right. Okay, so this is the acceleration of each block. Now we are going to calculate the normal reactions between the block. Let's solve N2 first. To solve N2, I'm going to draw the free body diagram of 1 kg block. So this is N 1 kg. This is 1 kg block. So N2 act on the block in this way. Obviously, I am neglecting the gravitational force and the normal reaction applied by the ground on the block, which because these two are in the vertical direction. I am only drawing the forces acting on the block along the x-axis. So as this 1 kg block have acceleration of 4 meter per second towards right, it means that the normal reaction N2 is acting on the block towards right, obviously, and this normal reaction is applied by the block 2 kg on 1 kg. Okay, so we have everything here. So the force is N2, so force equals to mass into acceleration. So in place of force, I am going to write N2 equals to mass equals to 1 kg and acceleration is equal to 4. So it comes out to be N2 equals to 4 Newton. Okay. Now we are interested in calculation of N1. All right. So we can solve the value of N1 either drawing the free body diagram of 2 kg or 3 kg, because N1 is the interaction of force between 3 kg and 2 kg. So we can solve from the free body diagram of 3 kg block or from the free body diagram of 2 kg block. So let's draw 3 kg. So to solve N1, so here we have a block 3 kg. So along the x-axis here 24 Newton force is acting, and here N1 is acting due to 2 kg block. So there are two forces acting on 3 kg, and 3 kg block is accelerating with acceleration 4 meter per second square towards right. As the acceleration is toward right, it means that force F is greater than N1. So the net force here F minus N1, which comes out to be 24 Newton minus N1. This is the net force. So net force is equal to mass into acceleration from Newton's second law. So net force, this is net force equals to mass into acceleration. Acceleration is equal to 4. So from this equation we can solve N1. It is 24 minus N1 equals to 12. So 24 minus 12 equals to N1. So 12 Newton. 12 Newton is the force acting between 3 kg block and 2 kg block. That is the normal reaction N1. In this way we can calculate the value of N1 and N2. We can, as I told you, we can calculate the value of N1 from the free body diagram of 2 kg block. So let's solve how we can solve that. So this is 2 kg block. Again, its acceleration is toward right, having magnitude 4 meter per second square. So this 2 kg block is under two normal reactions, N1 and N2. So N1 is acting in this direction and N2 is acting in this direction. Okay, I am assuming that we know the value of N2 from the free body diagram of 1 kg block. So N2 is comes out to be N2 is equal to 4 Newton. Yeah, so N2 is equal to 4 Newton. So let's solve this. So again, the net force, as the block is accelerating toward right, so the force which is acting towards right is greater as compared to force which is acting towards left. So N1 is greater as compared to N2. So N1 is greater as compared to N2 because the block is accelerating toward right. So the net force is N1 minus N2. This is the net force. Net force is equal to mass into acceleration. So N1 minus the value of N2 is equal to 4 equals to mass equals to 2 kg and acceleration is equal to force. So N1 minus 4 equals to 8. So N1 comes out to be 12 Newton. Again, you can see from either from the diagram of 2 kg block or 3 kg block, the answer is same, that is 12 Newton. So in this way we can solve the normal reactions where the three blocks are in contact. I hope you enjoyed the lecture and understand how to solve the accelerations of the block which are connected with each other on the smooth surfaces and how to solve the normal reactions. See you in the next lecture. If you are first time visitor, please subscribe my channel, share the content with your friend and enjoy it. In the next lecture, I am coming with how to solve the numerical problems based on tension in a string, where there are several blocks, something like this. Here are several blocks connected with each other with strings. So we will discuss such numericals in the next lecture. See you then. Bye bye.